Good morning. Welcome to Algebra 1 Honors. This is lesson 1-4, all about multiplying signed numbers. Okay? Now, if you go back to what you learned in third grade you learned how to multiply. And the rules for multiplying, what you learned is that it's a fast way to add. So if you had, for example, 0, we're gonna always start off with a 0 here. Plus 1, minus 1, this is our 0. If you added 3 groups of 2, so each group had a value of 2 and you added 3 of those groups, like right here. Here's our 3 groups that we're adding. 1, 2, 3. And they each have a value of positive 2. Then you ended up with positive 6. So in third grade, you only operated with positive numbers. In fact, we didn't even call them positive numbers. You learned all your multiplication tables. 1 times 1 is 1, 2 times 3 is 6, and so on. And you learned them with positive numbers, but we didn't call them that. Now we're going to move into the world of integers, which have negative numbers in them. So let's say that we extend multiplication just a little bit. What if we still added, so our top number is telling us the number of groups. So we added 2 groups right here, right, of -4. We start with 0. We always start with a baseline of 0. So here's our 0 right here, all with all our pluses and minuses that cancel out. And we add 2 groups, look like pickles here, or cigars. There's our 2 groups of -4. Well, adding 2 groups of -4 means we have 0 plus -8, and our answer is -8. Now, it gets a little more interesting, okay, when you move into, instead of adding 2 groups, okay, or adding 3 groups of something, you actually start taking away groups. And that's what we're going to look at right here. Over here. So in multiplication of integers or signed numbers, the top number now tells you whether you're adding so many groups or you are taking them away. The bottom number still tells you what the value of each group is. Right? So here we're going to be taking away 4 groups of +3. So that means that I'm going to put them sort of down here off the table. Okay? I'm going to gather up 4 groups, 1, 2, 3, 4. Okay? And these are going to be taken away. So although I'm going to put them down here, they really disappear. And each group has a value of +3. So in each of these groups down here that I'm taking away, I have to put 3 positives. So they're going to disappear because I'm taking them away. I'm not adding them like I was over here. Okay, so I'm going to take away 1, 2, 3 pluses there. That's my first group. And then I'm going to take away 3 pluses here. 1, 2, 3. That's my second group that disappears. Then here's my third group. 1, 2, 3. And here. Okay. And there's my fourth group. 1, 2, 3. Okay. So I've taken away 4 groups, and each group had a value of +3. Okay? Now remember, I just put them down here so you could see where they were disappearing. These are actually gone. Okay, they're not there anymore. We took them off the table. And so we want to see what we have left up here, because what we have left after we take away those 4 groups, what we have left is our answer. So if we take away 4 groups of +3, we're going to have, let's see, this one's a 0, so he doesn't count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 minuses. So our answer is -12. Okay, so if we take away 4 groups of positive 3, negative 4 times positive 3 gives us a negative 12. Now, let's see what happens when we do a negative times a negative. Right? Because most people can't explain to you why a negative times a negative becomes a positive. So let's look at it. So we're going to be how many groups we're taking away. Here, we're going to say minus 3 groups of minus 2 each. Okay, so we have to make our zero world first. Okay, that's probably enough zeros there. And then we're going to take away 3 groups. So I'm going to draw them down here, but remember, we're taking them off the table. 1, 2, 3 groups. And they're each going to have a value of minus 2. So I'm going to take my first 1, 2 minuses and put them there, gone. Take another 2 minuses, that's my second group. Minus, minus. Take my third group, minus, minus, and it's gone. Okay, so we've taken these away. Right. Now, let's see what we're left with. We're left with, let's see, all of these from here on down, all of these are zeros, so they don't really contribute much to our total. So we have to count 1, 2, 3, 4, 5, 6. We end up with a positive 6 because we've taken away 3 groups of minus 2. And as we take away the minuses, we take away the partner of the plus. Okay, so we end up having extra pluses left over as we take its minus partner away. So that's why a minus times a minus actually turns out to be a plus. Okay? Now, let's look at something else. So a minus times a minus is a plus. Okay? And a plus times a minus is a minus. Okay? And a plus times a plus, you already learned in 3rd grade, is a plus. If I add 5 groups and they're each worth 2 cents, then you have 10 cents, positive 10. Okay, let's look at something else about multiplying integers. All right, what happens if we have 2 negative numbers, 2 negative factors, and we multiply them together? Do we get a positive or a negative answer? Let's see if we can find a pattern here. Negative 2 times negative 3, there's 2 numbers being multiplied, 2 negatives. That gives us a positive 6. Right? Negative 2 times negative 4, that's a positive 8. Positive 8 times negative 3 gives us a negative 24. Ah, okay. Now we have 4 numbers being multiplied that are negative. See what we get here. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. And then negative 27 times negative 3 is positive 81. Okay, let's try this one. 5 negative numbers being multiplied. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 is negative 32. I begin to see a pattern. Let's see, let's try this one. Now, we already did this problem up to here. We know that's negative 32. 5 negative 2's all multiplied together is negative 32. And times another negative 2, negative times a negative gives me a positive. 32 times 2 gives me a positive 64. Let's do one last one and then see if we can find our pattern. Negative 5 times negative 1 is positive 5. Times negative 1 is negative 5. Times negative 1 is positive 5. Times negative 1 is negative 5. Times negative 1 is positive 5. Times negative 1 is negative 5. All right, let's look at, is there a pattern or a way we can predict if we had 99 negative 1's, let's say, all multiplied together here, 99 of them. Would our answer be a positive 1 or a negative 1? Well, let's see. It seems to be when we have an odd number of factors, an odd number of all negatives multiplied together, we get a negative answer. We've got 3 here, we get a negative 24. 5 here, we get a negative 32. 7 here, we get a negative 5. So 99 is an odd number of all negatives being multiplied. We're going to get a negative answer. And if we had 100 of them all being multiplied, okay, 100 of them there, all our even numbers of negative factors are going to give us a positive answer. Right? So that's something else that's in lesson 1-4. Right? Now I have 2 challenge problems for you and we're almost done. Right? Look up here and see if you can tell me what the answer is that goes in this box right here. That's a pretty icky looking problem, right? You're probably already saying, well, I can cancel here, right? And then, oh, can I cancel here? I don't know. Okay? Now, if you started doing that right off the bat, you fell in the smart kid hole. Okay? We're so used to being good at doing math that we automatically start calculating. We should look at the problem first, right? Before, just like they tell you to look before you cross the street, right? Smart kids love to calculate. But look at the problem. If you look all the way across, and you look right here, you get a 0 here. And what happens when you multiply anything by 0? You get 0, don't you? So if we had looked at the problem first, we wouldn't have done any work up to here. Right? Because no matter how many things I have multiplied together and how awful they look, the property of 0, the multiplication property of 0, says no matter how many things I have multiplied together, if one of them is a 0, I get a 0 answer. Okay? So look before you leap. Don't jump in and automatically start calculating just because you can. Okay, look at the problem first and see if there's something interesting about it. All right, the next one. So now I've kind of given you a heads up on the next one. What's going to go in that box? Okay, well, there aren't any 0's here, so you are going to have to do a little bit of work here. But the key is little bit. Okay, if you look across, your eyeballs are powerful little computers. Always trust your eyeballs. Your eyeballs should be telling you that, oh, looky here. 99 over pi and pi over 99. Eyeball, left eyeball says to right eyeball, oh, they're reciprocals. One is the other one upside down. What happens when I multiply reciprocals? I get 1, right? 2/3 times 3 over 2. You learned that in, I think, 5th grade. So when I multiply those two, I get a 1. Oh, and then your eyeball should still be telling you, oh, looky here. This one and this one, those are reciprocals also. So when I multiply them, I get a 1. Okay? And what allows me to mix up the order that I multiply there, because everything is multiplying. There's no adding or subtracting in there. Okay? The two properties that allow me to swap numbers around, if it's all multiply or all add, are the associative and the commutative property. Commutative property allows me to swap them. The associative property says I can multiply them together in any order I want. Okay? So, now I have 1 times, I still have that 100 left, because he doesn't have a reciprocal in there anywhere, times 1. And what's my answer? 1 times 100 is 100, times 1 is 100. And there's my answer. Okay? So, hopefully you didn't start number crunching right here and putting in what pi is, 3.14 or 22/7, because that would have been a really hard way to do that problem. All right? What we want you to do is think about some of the properties of math that make things a lot simpler. Okay? And then that problem is real easy. And that's all there is to lesson 1-4.